Okay, here you have, and you see I made the mistake here. You have, in fact, the screen pull, if you are the data extraction of those lines, and you can notice here then how it is organizing the data and how here it would be in the by layer where the color matches would be. So once you have this information here, if you remember I had a radial vector and a force vector, you can then start to sort by the layer, which will give you whether it's a radial vector or a force vector, and then the color, which does the matches. So in this case, I did not do that, but I'll go ahead and see if I can recover from memory. This one here was, we'll call that one, we'll make that, I guess, the red match. And that radial vector had a force down of, or force up of 50, and so I'll call that red. And of course the radial vector here, I'll call that blue. And where you generally, if you start with color 10, AutoCAD actually has numbers to the colors, and then that would let you kind of arrange and make you put up to maybe 200 forces if you need to in a system. And then you can go about, as you know how, I'm certain at this point, learning how to go here and do data sort. You can do sorting, and in this case we're going to sort first by, we'll put the red and the blue, and then we want the radial before the force, so we're going to sort by the color first, and then I guess it really doesn't make a difference, A to Z, and then we're going to go and add a level, and when we're going to go by the layer, and we want that to be radial before force, so we're going to go Z to A, and now we have in effect the radial force, which means you can then do your cross product. You remember I minus I, J minus J. You can kind of do that by Sarris's rule and get your calculation for moment, sum your forces, sum your moments, and you have what you need for that point in the system. Realize that then you can go back and change potentially what you're only changing if you're going up the spine at any one point in time. The only number you're changing will be the radial vector. So if you're going, let's say, 20 foot off the bottom of your structure, instead of this being a 50, it will be a 30 because you're only, you're cutting it at 20 foot above. So you can do manipulation and come up with the force and the internal force in the X, Y, and Z, and the internal moment about the X, Y, and Z axes, which will be equal to the opposite of these external forces. And you can take a look at that in class, but this is how one can go about and use your drafting engine, your vector engine, and your programming engine, be it Excel or your calculator or Mathematica or Wolfram Alpha, the sense that these radial cross product with the force cross product being important, I can't overstate. You would have most likely, depending on how one progresses through physics, looked at it already when you look at conservation of rotational momentum. And that means that in a closed system, for instance, a spinning skater, as within that closed system, the pull of the arm on the hand is an internal force. So as the skater pulls, or the swimmer or the diver pulls the mass towards the center, the rotational momentum stays the same. The moment of inertia is being reduced, therefore the angular velocity increases. So this sense of the cross product of the angular velocity being the cross product of r cross v over r squared being the same basic calculation of the moment calculation cannot be overstressed. And you'll see that as you play around in fun or AlgoRoo or whatever you're going to call funky physics or COMSOL or Inventor, this sense of the dynamic calculations being very similar to the static calculations. So that's it. This is close to the field. We'll take a look a little bit about updating, but Because of the ability to work in Excel, we're going to pull it out of AutoCAD instead of working within the AutoCAD. Thanks for listening.